Yes. So, hello everyone, and welcome to the live session. I hope you all are doing good. A very good morning to everyone. And we are discussing reaction mechanism topic. Since last week, we are studying this topic. And as you all know, this complete lecture series is going to be in English medium. And please excuse me for my voice also because I am little bit unwell. But I will try to keep my energy level high. So please cooperate with me. So in this lecture series, I have started reaction mechanism topic on the I think last week. Since we have started, we have covered lot of topics. For example, we were dealing with substitution reaction, and in substitution we have completed mechanisms like SN1 mechanism, SN2 mechanism, SNI mechanism, and we were dealing with the SNNGP mechanism, which is the one of the most important part of the substitution part. And we have seen few questions also, few previous year questions also, how they are asked in your exam. And in today's lecture also we will be seeing some previous year along with the concepts which we have to cover for the substitution part. Okay, so good morning Praful, good morning Diksha, good morning to each one of you, and I hope you all are doing well and your preparations for the coming exam is also going well. See, I think you must be having your BARC exam if you have filled the form, and you must be having your CSIR NET exam waiting ahead. So you must be preparing for both of these two. And of course, talking about CSIR NET, you have ample of time now also. You can add some topics in your syllabus if you have not completed. Still you have not completed some topics and you have given the last year attempt of December, and you have cleared a net exam, or you didn't clear GRF few margin, then of course you can supplement few topics also in your syllabus because you have time in your hand. Now, talking about this lecture series, first of all, I will be taking a recap what we have studied in the previous lecture, and then we will be moving ahead. Today, we are going to discuss very important concepts of Baldwin Rule, what is a Thorpe-Ingold effect, and I will be also talking about a case of OME, which I show you in the previous lectures that it behaves little bit exceptional. That we will also discussing, and we will also discuss the previous year questions asked on the same concept. Okay, so if you like the session, do share and like. It really motivates a teacher if you like the session and if you are present in a high attendance in the class also. Okay, so this is finally we have reached to our lecture number 6. We have reached finally to our lecture number 6, and of course we will try to practice some questions, but since we have left with some theory part also, we will cover that theory portion and then we will move ahead. Talking about the recap, yesterday we have started with the miscellaneous portion where I told you this miscellaneous is divided into these three sections. First is our NGP of sigma bond, second is our NGP in the larger ring, and third one is called as the NGP of an OME group. Now you can add two more topics in this miscellaneous only. One is called as the Baldwin rule. Here we also discuss in this miscellaneous part only, we have to discuss a rule called as Baldwin rule. You must have heard about this rule. This governs the cyclization of the rings in organic chemistry, whether a 5-membered ring rate of formation is fast, whether 6-membered is fast, whether 4-membered is fast. This is governed completely by Baldwin rule. In fact, you form cyclic products in many of the name reactions also. For example, in aldol reaction also you form cyclic product. There also the cyclization is governed by Baldwin rule. In radical chemistry, in intermediates, when you study radical addition reactions, there also the cyclization is governed by the Baldwin rule. So it becomes a very key factor for organic chemistry where you need to do the cyclization. And the second effect which is important is called as the Thorpe-Ingold effect. This Thorpe-Ingold effect has not been asked in CSIR NET exam yet. Though last year in West Bengal set exam a question has came from this Thorpe-Ingold effect. So since examiners are asking this question from this concept, there is a high probability that a question from this concept can be asked in your CSIR NET or GATE or set exam also. Okay, so this becomes important. any IIT JAM aspirant can skip this both part. They can skip the Ingold, Thorpe Ingold effect and the Baldwin rule. They can go with the basics of the NGP, what we have discussed, or they can simply skip the miscellaneous part also if the student is from IIT JAM and you are going to give any MSc entrance exam. Okay. So this is what we cover in the miscellaneous usually, and of course you can add few name reactions also. Moving ahead, in yesterday's lecture, we were talking about the NGP of sigma bond. Very important concept, and we have gone into the real depth of this topic. We have understood how a classical and a non-classical carbocations are formed. We have also seen that how non-classical carbocation leads to the final product. Correct. By seeing at the intermediate, we can comment whether the product is going to be a racemic mixture or they are going to be identical. Correct. These all things we have studied. Thorpe, Ingold, Fugdi wala. Okay. Good morning, Brajraj. Good morning, Spreadpeas. Good morning, Vikas. Good morning, Amrapali. Sir, is reaction mechanism PYQ available on IFAS chemistry app for practice? Yes, Pi, you can visit there. You will definitely find certain sections for practicing question. Okay. Good morning, Pooja. Very good morning. So we have discussed this topic in the yesterday's lecture. I have also talked about this intermediate, how it is formed. Yes, we have three forms of this intermediate. When I draw this into a single form, what we get is the non-classical carbocation. When I rearrange, this looks like this, and of course this has a plane of symmetry, so it is going to be optically inactive, and the products are going to look like this. We have already seen these topics. Okay, if you are new to this video, you are watching this video for the first time, I will strongly recommend you to watch the previous lectures also. There are a lot to learn and there is a lot of things which I have discussed. Okay, moving ahead, we have discussed again, I have explained you how books explain this concept. They do not go into the detail of the topic, they directly give you the intermediate to sometimes it becomes difficult for a student to grasp each and everything from the book. So there comes the role of the teacher. Now, these were the some theory parts. If you want to note down in your notes, you can also write it down, or you can write in your own language. Once you have understood the things, once you have understood the points, make notes, writing each and everything in your own language. For example, the rate of exocase is faster 350 times. You can also write the products are going to look similar, but in the case of exo, we get 100% racemic mixture, whereas in the case of endo we get only 93% racemic mixture. So you need to note down each and everything in your own language. Okay, so it will be better when you revise the notes, you get a better understanding. Sir, how can we define the non-classical carbocation? Uh, how can you define it? See, the carbocations which you were studying before this date when you came to know about the non-classical one were all your classical carbocations. When you see a non-classical carbocation, it's very simple to identify. The biggest discriminator is the three-center two-electron bond system. You can see that the non-classical carbocations which I have formed in this case, which I formed in the norborane case number 4, they both are three-center two-electron system. And the carbocations which you study in day-to-day life are simple carbocations. They do not form such type of systems. Okay, this is the biggest differentiator, or you can simply see that the carbocation is roaming at three centers. When they can roam at the three center, then also you can say it is a non-classical one. Okay, so this is how you need to identify one non-classical carbocation. Now I have explained you these things. You can have a reading of this also. If you want a more clear-cut picture, for example, they have uses the references of the scheme. You can visit P.S. Kelsey, as I have taken this theory part from the P.S. Kelsey book of reaction mechanism. PS Kelsey do not cover everything holistically. What happens is we get some topics in PS Kelsey, we get some topic in Carey Sandberg, we get some topics in reaction mechanism. For a student, it becomes difficult to compile all the thing and study in one at one place. So there comes the role of a teacher where he or she compiles each and everything and provides you in a single notes so that you are able to understand every concept. Okay. There is a possibility of formation of non-classical carbocation. You are very correct, Vasu. When the ring breaks, there are three possibilities: whether a four-membered ring can be formed or whether the ring can break. The scenario of dancing resonance. There are also a non-classical carbocation forms. Yes, you are thinking correct. Okay. Good morning, Karishma. Very good morning. We have gone through these concepts we have discussed. Now, since there is a small rule called as Baldwin rule, I will be discussing this and then I will be coming on the question part. See, Baldwin is a simple rule that governs, that tells you about what is going to be the rate of cyclization. It means whether a five-membered ring will be cyclizing fast or whether a six-membered ring is going to cyclize fast. So what happens is Baldwin rule does not tells you about the stability of the rings. Students get confused. They say that, sir, six-membered ring is more stable, then why it is not forming? Baldwin rule is not commenting on the stability of the rings. Yes, six is stable and it is going to be stable. But here we are comparing which ring is forming with a faster rate. So what we observe is what Baldwin has given to us is he has told us that a five-membered ring of cyclization with a very fast rate, then comes your six-membered ring, then comes your three-membered ring, then seven, then four, then eight. You need to remember this order by heart. You need to find two important things here also, that three-membered ring is present here. A four-membered ring has a very slow rate of cyclization. It is even slower than a seven-membered ring. So you need to memorize this order by heart. दिन में दो तीन बार आपको सुबह शाम इसको लेना पड़ेगा, ठीक है, और याद हो जाएगा. Yes. If you want to know about this, since Vasu is commenting that, sir, since this Baldwin rule is given on the basis of thermodynamic and the kinetic aspects, see, there are two factors which control this Baldwin rule. One is your enthalpic factor and one is your entropic factor. One is your enthalpic factor, that is called as delta H, and the second is your entropic factor, that is delta S. They both governs your rate of cyclization. If you want to study this topic, Baldwin rule, in a great depth, if you want a real command on your organic chemistry, because this is going to be used in reaction mechanism, this is going to be used in reagents, this is going to be used in intermediates. So you must learn what is Baldwin rule and how it has given this order, and there are more aspects, some more aspects of the Baldwin rule also. So you need to visit IFAS chemistry channel, the same channel on which you are watching me. I have completed this Baldwin rule. I have taken 6 lectures on this Baldwin rule, and you can go through that. Your each and every doubt regarding Baldwin rule will be clear. I have covered this Baldwin rule in a very holistic manner. I have given you examples from even research papers also, that what are the exceptions of Baldwin rule, what are the examples which are asked on the basis of Baldwin rule. I have given you the previous year questions also. So this, if you want to complete your Baldwin rule in a very holistic way, you can go through this lecture series also. Okay. Yes, Pooja. Baldwin, you should remember this, like you have remembered your phone number, you should remember this order in a similar way. Okay. 5, 6, 3, 7, 8, 10. Very good. Therefore, exoepoxide ring opening in norborane by S3O plus attack of nucleophile on a classical carbocation. Please explain. I did a ring rotation, then I got correct product. Is it correct? Exoepoxide ring opening. You are doing the norborane system and the water is attacking. Okay. I did the ring rotation. Why you are doing ring rotation? I am not getting that point. Ring means you are rotating the your ring, or you are just rearranging the ring. There are two aspects here, spread please. Okay, so these are the things which you need to learn for the Baldwin rule. I will give you a small example. For example, this has been asked in your NET exam. They have asked you the order of relative rate of cyclization of the following bromocarboxylates to generate the corresponding lactone is. They are saying that from all these three substrates, we can generate certain lactones. So can you tell me what is going to be the rate order for them? It is a straightforward question on a Baldwin rule, what we have studied now. There are a lot of questions like this on the Baldwin rule, which I have discussed in this lecture series. So you need to go and see if you want to learn Baldwin in a very holistic manner. Okay. So coming to this question, when we do numberings in order to find that how many member ring is formed, so what we have is a 1, we have 2, we have 3 and a 4. So in this case, we have a 4-membered ring. When I move to the second case, what I have is 1, 2, 3, 4 and a 5. Here we form a 5-membered ring. Here we have 1, 2, 3, 4, 5 and 6. Here we form a 6-membered ring. If we don't know about the Baldwin rule, what we are going to do is we will be saying that the rate of formation for C is going to be fastest. But Baldwin rule plays an important role. He has given you the idea that yes, 5-membered ring rate of cyclization is very fast. So B is going to be having the highest rate. Then comes your C and then comes your A. So this is going to be the order of cyclization. So when we look at the options, which option is going to be correct? So option number C is going to be correct. It was a very easy question based on the Baldwin rule. Did you get the concept? It was very easy. There was nothing that you will not get here. Okay. Similarly, similar to Baldwin rule, there is one more effect which is called as Thorpe-Ingold effect. What does a Thorpe-Ingold effect tells us? Again, I have explained this effect also in the Baldwin rule lecture. You can go through that. Thorpe-Ingold effect says that uh, Thorpe-Ingold effect is the way in which the substituent on the ring increases the rate or the equilibrium constant for the ring formation for the ring forming reaction. What they are trying to say is, when you are doing cyclization and you are comparing same member of rings, it is very important that you are comparing same member of ring. For example, let's suppose for a while you don't know that what's the rate, what is the rate they have given here. Close your eyes for a second. I am removing these things. Now, we don't know about the rate of the cyclization. Now, we have to compare it. Okay. So, for the first scenario, what I am seeing is this O minus is attacking at this center and the Cl is getting removed. And here also this is attacking at this center and the Cl is getting removed. Okay. Let's suppose I told you this is going to cyclize via K1 rate and this is going to be cyclized via K2 rate. Now, I need to compare the rate of cyclization. Now, Thorpe-Ingold says that if you increase the number of substituents on the ring, or you can say on the chain, your rate of cyclization is going to increase. But how? The number of substituents playing an important role in deciding the rate of cyclization. See, here we can explain on the basis of entropic factors, that is delta S, or you can say the randomness, or you can say the disorderness of the chain. Let's suppose we all know that the sigma bonds rotate very well. So in the first scenario, this rotation is taking place and the O minus is getting very less chance to attack into the sigma star orbital of the CCl and eliminate the Cl. Whereas in the second scenario, when I have increased the number of substituents, when I am increasing the number of substituents, what's going to happen? The amount of rotation about this chain is going to decrease, because I can say that the disorderness of the ring is going to decrease. Since the disorderness has decreased, the rotation extent has decreased, so there is a higher probability that this O minus is going to attack on the Cl center, carbon center, and will remove the Cl. So what happens is, as we have increased the number of substituents, the rate of cyclization for K2 is going to be higher as compared to K1. Are you able to digest this concept? Tell me fast. Are you able to get it or not? Restricted rotation of sigma bond. Very good, spread please. Good morning, way to IITs. Good morning. Number of orientations decreases if the substituent increases. Very good. This is also a way to explain that number of possible orientations, that the probability of attack increases. These are the different language to explain the same thing. Very good. Similarly, there are few more examples. So this was our example number 1. I have taken this examples from your Claydon book only. And let's suppose I have one more example. Just for a second, close your eyes or don't look here, okay? I am removing these rates. What you need to tell me is the order of rate of cyclization. Here also they are forming a lactone ring. We have a K1 here, we have a K2 here, and we have a K3 here. Can you tell me what is going to be the order for K1, K2, and K3? And similarly, here also, can you tell me what is the order for K1, K2, and K3? In the first case, it was K1 and K2, and here we have K1, K2, and K3. So we have three questions again. What I have written is at this center we have K1 and at this center we have K2. Moving ahead, we have K1, we have K2, and at this center we have K3. The same question was asked in West Bengal set exam. They have picked this question from the Claydon book only. Set exam of West Bengal, they asked the third question. Now you need to answer me all the three. For the first question, question number 1, we can say when we observe the rate of cyclization, what we find is since in the first case the number of substituents are very less, so the randomness of the ring or the disorderness will be highest. So the probability of attacking at the carbonyl center is going to be very less. Whereas in the second case we have two substituents arranged here, and in the third case we have, okay, there's a misprint here. We should have two CS3s present here, okay. So sometime Claydon book also do misprint, so don't panic. So what we have in the third case, we have CS3, CS3, 4 CS3s. So in the last case, the orderness is going to be, disorderness is going to be decreased. The entropy will be very less. So the rate of K3 is going to be fastest. Then comes your K2 and then comes your K1. So we are discussing some reference book questions. Okay. So K3 will be having the fastest rate, then K2, then K1. Very simple. Now you need to tell me for the example number 2. What do you think? If I am moving to the example number 2, where I am forming a 4-member ring, remember when we compare the rate of cyclization via Thorpe-Ingold effect, they should be of same member ring. For example, you cannot compare a 4 and a 5-member ring. There a Baldwin rule is going to decide that rate. But if you are comparing 4-member with a 4-member, then only you can apply the Thorpe-Ingold effect. Okay. So Prabhat Camp Pacific. Yes. For the second scenario, what we have is in the first case, we don't have any substituents attached here. But in the second case, we have two CS3s. So the entropy is going to decrease. The rate, the possibility to attack at the carbon center is going to increase. So rate of K2 is going to be faster as compared to K1. The third question is little more interesting here. Now you need to tell me for the third one, what is going to take place. Fugri effect, Thorpe Ingold. Very good. This type of substituent as electron withdrawing or donating affects the rate in a different way. It might affect if your nucleophilic center is in kind of resonance with it, then a effect can be observed. But in Thorpe Ingold, they are not going to place some withdrawing or donating groups like minus M group or such type of groups. They are not going to ask you on that basis. Okay, they will simply ask you on the basis of entropy. Okay, Akansha. Yes, the third scenario is little bit more interesting, as in the first case we don't have any substituent. It is clear cut that the rate is going to be slowest. So I will be finding the options in the exam where K1 is going to be slowest, and I will remove the options which does not have K1 with the slowest rate. So what is going to happen? You will be removing the two options and you will be left with two options. Now, if you have studied this concept, you will be able to answer. Otherwise, you are going to do. Otherwise, you will be doing your tukkification. So what we have is we have a CS3 at this center, two CS3 placed, and in the third scenario also we have two CS3 placed. It means the number of substituents are going to be same, but examiner has changed the position of the substituents. Now what you think, what is going to take? What is going to happen here? Just change this, just he has changed the position only. See, what is going to happen is we have to again think on the basis of entropy only. In the last scenario, this CS3 and this chain is going to repel each other, and this CS3 and this chain is going to repel each other. So the CS3s, because of their repulsion, they are going to squeeze the NH2 and the Br center very close to each other. So there is a higher probability of attacking this center at the carbon of the where the Br is attached, whereas in the second scenario the repulsion is only taking place at the NH2 center, and this type of repulsion is very less in magnitude. So the Br, the chain of Br is still in a lot of disorderness, and it is still rotating very well. So by seeing the repulsion, we can say that yes, the attack in the case of K3 will be more preferred as compared to K2. So here number of substituents were same. Here the number of substituents were same, but because of the different position and because of the squeezing of the two chains, the rate of attack in the third scenario was really high. Are you able to digest this concept? Tell me fast. Yes, वेरी गुड कैम पैसिफिक. अगर बीच में सब्स्टिट्यूएंट लगाया है तो दोनों साइड से दबा देगा और अटैक करने की प्रोबेबिलिटी को बढ़ा देगा. तो these are the three famous questions for Thorpe-Ingold effect which you are mentioned in your Claydon book. Okay, very good, excellent, excellent. So what we have seen, we have covered, we have seen that we have to study Baldwin rule also. I have told you the order what a Baldwin rule tells us, and we have covered the Thorpe-Ingold effect. Now comes the a very important case of the miscellaneous, what we called as the case of OME. When we have a OME group as a neighboring group, when we have this OME as a neighboring group, then we need to decide what is going to happen. First of all, we will see what Claydon tells us. These both examples has been taken from the Claydon book only. They says us that when you take an OTS group, for example, let's suppose this is a living group. Living group is attached to the alpha position, and you take a OME group which is placed at the a beta center. In such a scenario, the rate of reaction is exceptionally slow. They say that this react with ACOH 4 times slower. Oh my god. 4 times slower as compared to the second substrate where no neighboring group is present. Are you able to get this concept? Now, Claydon says that what's the reason behind this? They say that first I will be reading the statement. The OME group slows the reaction down just because it is electronegative more than it accelerates it by participation. It is saying that the OME oxygen atom, being electronegative in nature, it slows the rate of the reaction more as compared to the it increases the rate of reaction by neighboring group participation. ये रिएक्शन की रेट को धीमा कर देता है एज कंपेयर्ड टू द केस व्हेन ये जब रेट को बढ़ा रहा होता है। और इसके पीछे रीजन क्या बताया गया? इट इज द इलेक्ट्रोनेगेटिविटी ऑफ द ऑक्सीजन एटम। फिर दिमाग में कंफ्यूजन आता है कि सर OAC ग्रुप भी तो ऐसा था। When we have a OAC group, this was also a very similar case. See, when you write OAC group in a neighboring group, this oxygen does not participate as a neighboring group. When we open this AC group, what we find is the oxygen present at the carbonyl center participates in the ring formation, and then a three-membered or five-membered ring is formed. But in the case of oxygen, these rings form a three-membered ring, which is not favorable for an atom like oxygen. That's why the rate in this case is 4 times slower as compared to this. So what does this mean? Sir, OME is not going to behave as a neighboring group. It will behave as a neighboring group, but you need to place your OME a little further away. For example, 1, I have 2, this is 3, and this is 4. When I place this OME at the fourth center, and there is a possibility for formation of a five-membered ring which has the highest rate of formation, then of course your NGP is going to take place, and this is going to be 4,000 times higher rate as compared to this substrate. Are you able to digest this or not? There is a little bit exceptional case with OME. If I have a nitrogen in the place of oxygen, yes, the reaction will take place, three-membered ring will form. But since oxygen is little more electronegative as compared to nitrogen, the three-membered ring formation is not preferred. Are you able to digest this or not? CSIR NET has asked 2 times a previous year question on the same concept, on the concept of OME. If you have understood this, then I will be taking few examples and I will show you how the product formation is taking place here. Is this digestible? Then I should move ahead. Please note down each and everything in your notes and follow the sequence which I am following, so that once you revise your notes, everything is placed and stacked in your brain in a proper manner, so that you are not confused. Okay. Now, I will be coming to this question, but before that, I need a blank slide in order to explain you something. Let's suppose I am dealing with a case where I have a OTS as a living group. Now, what I have decided, I will be placing my 1, 2, 3 and OME group at this center. Okay, I am removing one CS3. This is our substrate. We know that yes, now this OME is going to behave as a neighboring group. It will be removing the OTS, sorry, and a five-membered cyclic transition state is going to form. This is how our transition state is going to look. If I do the numbering, this oxygen gets the number 5. So I have a CS3, or I can say a Me group present here. Since oxygen forms 3 bond, it is going to have a positive here. This is carbon number 5. Let's suppose this is carbon number 4. It is going to have a CS3. This will be 3, this will be 2, and this is going to be 1. Now, I have taken a nucleophile, let's suppose ACOH. This ACOH has two choices to open the ring. Once the attack can take place at the carbon number 1, and in the second time the attack can take place at the carbon number 4. It means here are two possible products which I can form. One by attacking at the carbon number 1 center, and the second by attacking at the carbon number 4. Now, how the products are going to look like? I will be drawing the products also for you. First of all, let's suppose I am drawing for the when the attack takes place at the 1 center. What happens is ACOH attacks and the rings open from here. So carbon number 4 is going to have a group that is called as OME. Moving ahead, carbon number 3, this was our 4, then comes 2, then comes your 1, and the 1 center has your nucleophile, which will be our OAC group. So this is how the chain moves, and we have a OAC group. This was 3, this was 2, and this was 1. When I compare this product with the starting material, what I find is the OME which was placed at the fourth center is now also placed on the fourth center. The OTS which was at the 1 center has been replaced by the nucleophile which is placed at the 1 center. Such type of product are called as normal NGP product. Normal NGP product. Very good. Now, when we will observe the product for the second scenario, that is when we attack on the fourth center, what we going to find, what is we going to observe is now the carbon number 4 is going to have the OAC group. Moving ahead, because attack will take place and the ring is going to open, and the carbon number 1 is going to have the OME. This time I will be doing the numbering for you, 3 2 1, and yes, this was the our 5 center. Now, when I compare this product with the starting material, what I find is now the carbon number 4, which was having the OME, is now having a OAC group, and the OME seems to rearrange from its initial position and it has now moved to carbon number 1. So such type of products where a OME group appears to have moved from its original position are called as a rearranged NGP product. Such type of products will be called as a rearranged NGP product. Are you able to digest this or not? Now, my second question will be, tell me whether a normal NGP product is the major product or the rearranged NGP product is the major product. Can you tell me that? How you are going to choose the major and how you are going to choose the minor product? This becomes really important. See, if you have learned about the epoxide openings, with unfortunately I have skipped that topic, not unintentionally, so I will be covering in any one of the lecture, don't worry about that. So what we have going to observe is, since the oxygen has a positive charge, it is going to pull the electrons from the both the side because its minus I effect has been activated. Now what is going to happen? It is going to pull electrons from both the sides and it will be creating a delta positive at carbon number 1 and a delta positive at carbon number 4. Now a delta positive at a more substituted center are usually more stable. It means I can say that yes, the delta positive at carbon number 4 is going to be more stable. So of course, the attack when take place from the fourth center is going to give you the major product and this is going to give you the minor product. Claydon book is not going to tell you about the major and minor. Again, you need to move to some other book to find this result. That's why a student faces difficulty in studying a topic from a single book. They does not get each and everything compiled in at one place. That's why these notes become very important for you, so that before exam you can revise each and everything where every concept from every book has been taken, and that's the role of a teacher. So this is the product which is going to be major. On the same concept, question has been asked in your exam also. We will be seeing that previous year question also. Okay, in the case of epoxide opening, then if alcohol is a nucleophile, then it will prefer to attack from the, yes Vasu, this is the concept. There are few exceptions also. For example, in the epoxide opening, one is the case of HBr. You need to take care of that. That is also mentioned in the Claydon book only. Okay. Yes, very good, Akansha. This is the same concept which we are applying. Excellent. So the rearranged NGP product is going to be the major product. Let's take a previous year question also asked on the same concept. This is a question which was asked in December 2016. Have a look at this question. They are saying the correct statement, you need to identify the correct statement if you have two reactants A and B and you have two products also which are C and D. You need to identify which statement is correct here. these are the same cases what we have discussed now. These are the NGP case of OME only. What you need to identify, what you need to interpret is the statements they are giving in the option. See, let's suppose you don't know anything. We should proceed with the question. We will attack this oxygen lone pair at this center. The living group will be eliminated. We are going to have a 5-membered cyclic transition state. Oxygen is going to have a CS3 present here and with a positive. The center at which we have attacked is going to have a CS3. This is how our cyclic intermediate will look when the neighboring group participation takes place in the case of A. And similarly, in the case of B, when the oxygen attacks, this is going to removed. Again, you have oxygen, and oxygen is going to have a CS3 with a positive, and at the center where the OMe group is attached is having the CS3. What we observe is the intermediate in the first case and the intermediate in the second case are going to be similar. They are looking same. Now, there are two possibilities. You can draw two products from here also. You can draw two products from here also. Of course, the amount of products in the first case is going to be the similar as in the case of second. So the option number C, which is saying that A and B gives identical amount of C and D. What they are, it is not saying that you will get an equal amount of C and D. They are saying amount of C and D you are getting from the first case is similar as to that what you are getting in the case number 2. What students do, they interpret that statement number C is saying that C and D are coming in equal amount. This is not what the statement is saying. Statement is saying that the amount of A and B you are getting from A is exactly similar that you are getting from the second intermediate. And yes, this is the true statement. So option number C is going to be correct. Did you got the concept or not? A very easy question which was asked in December 2016, and based on the same concept they have repeated a question in December exam which held in 2023. So it's very important to solve previous year questions from 2011 to till date, because you have ample of questions to practice each and every question of previous year. Okay, now coming to the question they have asked in CSIR NET. This was a little lengthier question. It will take some time to solve because they have mixed a little bit of stereochemistry in this question. But again, if you have a little patience, you can solve this question very quickly also. You can reach to the correct answer. And this was a question of 4 marks. So of course, if they want to take you 4 marks, you need to solve, of course you will invest a little more time here. Okay, now tell me what is going to be the product. A product, not they have given the product, they're asking about the reactant. Which two reactants are going to give you the products which are going to look like this? This is the question. One of the product is, you can see that one of the is a rearranged product and one is your normal NGP product. Good morning 45. This question I have left an exam. Why you have left this question, Diksha? It was a question which is very much doable, but yes, it will consume a little bit of time. You need to devote a little more time to this question. And it was easy. You can do that. Now try this question right now. They have given you 4 reactants and they are asking you which options are going to be correct. They are confusing you in the stereochemistry part. See, in this scenario, when we look at the substrate, we find that 1, 2, 3, 4, 5 and 6. It means this is a case where a 6-membered transition state is going to form. Okay, so our transition state will have a intermediate is going to have a 6-membered ring, and of course a methyl will be present here with a positive charge. But the twist here is about the stereochemistry. What you find is at this carbon center, which is carbon number 5, we have a substituent which is placed below the plane. Now we know that at this center we don't have done any reaction, so the stereo of this center, or we can say the configuration of this center, is not going to change. It means if I find the RS configuration at this center, it is going to be same as in our reactant also. For example, let's suppose this was our carbon number 1. I have kept this carbon number 6. This is going to be 5, 4, 3, 2. Okay. Now at the fifth center, I have placed this methyl below the plane. For a second, to check whether this is correct or not, I will be finding the RS configuration in order to double check this. So if I find the RS configuration, what I find is the first priority is given to this center, the second is given to this center, and the third is given to this center. This is a clockwise rotation. Fourth priority is above, it means it is going to be S. Similarly here also, first, second and third, it is going to be 1, 2 and 3. Clockwise rotation, it means yes, I have written it correct because this is also the S configuration molecule. This is what I am going to get. Now, there are two possibilities. Either the attack take place from the second center, either the attack can take place from the carbon number 1. And of course, two products will be forming. One will be your this product and the second is going to be your this product. In order to confirm the stereochemistry, what I can do is I can again find the RS configuration of these centers. So this chiral center again have a S configuration and this also has a S configuration. It means yes, the A option is going to be the correct one. So I can eliminate the second and fourth. Now I need to check between B and C, which is going to give the same intermediate. Between B center and between C center, I need to check which will give the same product. If you are smart enough, you can just find the products by finding the RS configuration. You know that at this center configuration will be, if I find 1, 2 and it will be of course a clockwise rotation, it is going to be R. But the product says that the substituent with the methyl is going to have a S configuration. You need to cancel this and of course option number C is going to be correct. So if you have practiced lot of question before the exam, of course you can apply such concept. But since this is a new question, you are in examination pressure also, so it will take time. If some questions are difficult, they are asking time, then do it in a separate time. When you have completed your uh, paper, you are in a comfortable zone, then you need to attempt and devote some time to these questions. Okay, I can draw the product also. Let's suppose when I took the B1, what is going to happen is now this OME is going to attack here and the OTS is going to be removed. So now again we will be forming a 6-member ring. This oxygen is going to have the methyl. I will be doing the numbering. This is 1, 2, 3, 4, 5 and 6. Positive charge, this was 1, 2. Now the 3 center has a CS3 that is above the plane. Now in order to confirm the stereo, I can match also, or you can see that these two intermediates are similar. When you flip the second intermediate, what you get is the first one. Then of course this is also going to give the same product as the first one. You can go by this also. You can just check whether the cyclic intermediates you have formed is similar in which case. So when you go via A and B, they are similar. Are you able to digest this question? There are a lot of ways via which you can reach to the product. The concept is going to be same. The only examiner has confused you in the stereo part. They are going to be same. So of course the products are also going to be same. You can also confirm with the RS configuration. This is going to be 1, this is going to be 2. So 1, 2 and 3, this is going to be of S configuration. This is also S, this is also S. And the products also have S configuration. Of course, then straightforward you can say that option number 3 is going to be correct. 4 marks. We can easily secure 4 marks here. Okay. So this is how you need to attempt organic chemistry questions. If let's suppose you are giving a attempting part C, and in the starting half an hour you have came across this question, of course you have to skip this question for that time. Once you have solved the whole part C, you have marked this question in a review, and after let's suppose 2 hour and 2.5 hour, when you have comfortably completed your paper, now you are finding those questions where you can gain extra marks. Then you have to come back to this question. You need to invest more time because you have studied NGP reaction. You can do this question. Just have confidence on yourself. And yes, this question will demand time. Okay, this is not something that you will get into one go. There will be questions which will take some time, which will take that can take 5 minutes even, and there will be question also which are going to take place, which will be happening in just seconds, either in 10 seconds, 30 seconds. So you need to differentiate the questions. Don't panic that this question is taking a lot of time. Yes, that is meant to take time. Okay, so be in a right and a proper mindset before the exam. Be ready for such type of questions. Okay, rest, I'm winding up the session for today. There are a lot of questions more. You can practice this question in homework. From Monday onwards, I'm going to come live on the 5 o'clock in the evening, and I'm going to start an organic spectroscopy topic. I hope you people will join live there also, and that is going to be in a Hindi medium. This was for the English medium or the students who face Hindi language as a barrier. I hope you enjoyed this NGP part. You have enjoyed this substitution part. There is lot to discuss in a mechanism and lot things which is still to be covered. Okay. Yes, spread please. What is your doubt? Okay, so thank you so much. You can practice these questions. They are from your previous year exam, previous year questions only. Thank you so much. Take care. Bye bye. And we will meet on Monday. Sir, epoxide, exo-epoxide opening of S3O plus. Well, see, it depends whether at the nor-boron system you have anything or not. Okay, there can be two things: whether this ring can rearrange or whether an attack can take place from the direct center. These are the two possibilities. Okay, spread please. If you have at the bridgehead center you have a CS3, then definitely the ring is going to rearrange itself. The bridgehead centers are going to change their position. This is what I think you are confused in. Okay. Thank you so much. Let's meet on Monday.